So, I'm in. Okay, good evening, everybody. Thanks for attending. Thanks to the organizer for giving me this slot to speak. And this talk will be about my few months experience at the core team of Alastria as a volunteer. Alastria is a nonprofit association based in Spain to promote digital economy. It has over 500 European members, and it runs 3 private blockchains. I will focus on 2 of them. One is based on Quorum. It has over 140 nodes. The other one is based on Hyperledger Besu, which has over 20 nodes. There is no silver bullet here to monitor, nothing really, there's no single solution out of the box. And there are different approaches like WebSockets, scraping, pushing, forwarding. And we aim at enrich out of the box time series database metrics, okay? So the products again are Hyperledger Besu by Pegasus and Consensus Quorum, which has been acquired to JPMorgan 1 or 2 weeks ago. I won't be speaking about Tessera and Orion, which are the private components of both technologies. Basically, Go Quorum is a Get client. It's written in Go. Pegasus Besu is written in Java. What's a private permission network? There must be an association behind, and you have to sign an agreement or a contract because this association anyhow dictates the governance of the network. So you have some duties, and there is also specific architecture. It's not like in mainnet where you have nodes and miners. Here you have regular nodes where people can host their applications or middleware to bridge their applications. There are boot nodes, which are the nodes that ensure that only permission nodes can join the network, and there are validator nodes. So this is, again, no proof of work. It's rather proof of authority, and it's driven, in our case, by Istanbul Byzantine Fault Tolerant consensus protocol, which is wired into the genesis.json file. The approval of transactions happens by a supermajority, by voting, and there is also voting to remove and add validators. So it means that there are also validators in standby mode. With regard to incentives and rewards, you know that in mainnet there is mining, so you can get either as an incentive or as a reward. Here there are reputational, marketing, and economic reasons why you might want to run a node. For example, if your organization runs an application that needs a lot of processing power or a lot of TPS, which is transactions per second, there might be economic reasons why you put in a strong hardware. The nodes are managed by participating organization. So this is not as easy as monitoring your own infrastructure, where you have the keys or the accesses to everything. The software is distributed through microservices, so you always have a chance to distribute some software that's accompanying the main software to monitor, and there are no constraints on where you're going to host your node in any public cloud, on-premise or whatever. And there are just a few requirements regarding open ports so the protocols can flow. And there are members with regular nodes who can refuse to be monitored. I mean, it happens. They might have different reasons, maybe company policies, or I don't know, maybe they believe they can get trapped into a single point of failure or a bottleneck or whatever, or they think that monitoring slows their nodes down. But it can happen. To make it easy, the get client, which is written in Go, when you run it with the -- permissioned option, it will look for the permission -nodes.json file with a list of nodes that are permitted to access the network. So there are many sources of metrics. Again, they are all partial. I will enumerate them here. First of all, the easiest one is out of the box by get. You can push measurements to a remote Influx CB server. You can push metrics to a local Prometheus exporter to be scraped by a remote Prometheus server. This is present in Hyperledger Besu and in Get, but starting at version 1.9. So an exporter is basically a very small HTTP server where you ask to get /metrics and you get a bunch of metrics for Prometheus. Then again, there are nodes that don't want to be scraped because of company policies or firewalls or whatever, and they can be configured in Besu to push metrics to a Prometheus push gateway, okay? Then you can parse logs. For logs, we've been attempting to do it with Telegraph, which is part of the Influx stack, but you have to have the right grok patterns and send them to Influx or Prometheus. This is not very easy, as you need the whole repertoire of possible messages. I've seen plenty of messages that were pretty weird. I've seen crashes, runtime errors, and there might be perhaps a previous step, which is log shipping to a central location like Elasticsearch or Splunk, and study what's going to be the whole repertoire. Then there is something interesting, which is WebSockets. We've set up a WebSocket server to listen to ethstats. Ethstats is something that's only available in Get. Get spontaneously generates a stream of JSONs over WebSockets, which you know is built on top of HTTP. And when you have this kind of WebSocket server, you have to render the information into your screen, or you can use you can have an API to retrieve the consolidated information. I will circle this back later. And the preferred way is a monitoring artifact that you construct by yourself, talking RPC to both Get and Besu, and producing, for example, an exporter for Prometheus, produce Influx CB, push Influx CB measurements, or generate ETH-stats WebSockets traffic. A little abstract background to know what we're doing. Here are the 4 golden signals from Google's System Reliability Engineering book. And we'll try to map it to Ethereum networks. Well, latency in our case would be time taken to process a transaction. There might be smart contracts which are heavier and lighter, I mean, which consume more or less gas. And then there is time taken for consensus, and there is also a network latency. with regard to traffic, there is not much demand in Ethereum private networks. It's usually in the range of a few kilobits per second, which is nothing in comparison to CDN with many megabits per second, which is what we are used in Planisys. In errors, you will be mostly looking at Ethereum virtual machine errors or crashing clients and saturation. This is very important in Ethereum. So what you're looking for is what's the max TPS of your network? I mean, what's the peak transaction per second you can reach in your network, as you have to think of Visa or Swift processing millions and millions of transactions per day. So this depends on your Ethereum software and your architecture, and there are tools out there like Hyperledger Caliper or Apache JMeter, or you can do your own scripting as well for stress testing. So what we're going to do is based on the red method with an eye on saturation, okay? Here, a request is basically a transaction, or it could be also a block, because transactions in Ethereum are packed into blocks. The rate is the number of requests per second. Again, blocks per second, which is anyhow the heartbeat of the network, and transactions per second, again, TPS. The errors are the number of failed requests. Here you can have a variety of Ethereum virtual machine errors, rejected transactions, out of gas transactions, runtime errors, connection refused, and other networking messages. The duration for the D is the amount of time the transaction spent. Again, there might be heavy versus light smart contracts. There is a validator's performance, which is key, and how it affects the TPS. There might be latency due to network or to architecture, or the amount of time where there are pending transactions. I'll show that in a Grafana dashboard right away. So mainly what users want to know is if their nodes are up and synced to the last block number. I mean, if they have the same word state, I mean the same copy of all the blockchain, or said in another way, if they are at the blockchain height. We observed that there are 3 levels of monitoring information. The first one is the typical individual node virtual machine information, which is pretty much out of the box and well known. Then there is a traffic level where you will see protocol-related information to ETH or peer-to-peer. And at the higher level, you will see transfers, tokens, gas, and transactions. This one is a proof of concept. I grabbed the GitHub repo of a very clever guy who wrote Prometheus exporter in Go that I linked to Quorum, which is slightly different to regular Go Ethereum. And it produces this dashboard. Okay, so you can see here transactions and pending transactions. Then running a Hyperledger Caliper stress test. This is the representation of the last 15 minutes. The test was configured with just one worker. You can configure many parallel workers. And what you see is that at some point, the yellow bars mean that they're pending transactions. So the network is slowing down. And the peak of transactions of this test was 136 or 37, okay? At another test, we see a completely different scenario. 8 workers, it's almost the same test. I mean, you can configure the parameters of the test, and we see a dramatic increase of pending transactions at 1425 or something like that. And if we look at another graph that I will explain later, this one belongs to a Grafana dashboard of InfluxDB. I mean, this is the out-of-the-box information provided by Geth. You will see that there is a thing called gapped rate limit. So somebody hits a rate limit here in a validator. This graph corresponds to a validator, and then it's exactly at the same time where we start having pending transactions. This Grafana dashboard corresponds to Telegraph, which is part of the InfluxDB stack. Nothing special in the push to InfluxDB. And the things you have to keep in mind here are the load average and the IO weight parameters. And there is no much pressure on the node. And this happens in most of the nodes. I'm showing here a boot node by Planisys. Etstats is quite interesting. You can open this option /etstats, your node name, colon, a secret of the Node.js server, the IP address or FQDN and the port, and then Geth starts sending streams of WebSockets in form of JSONs to our Node.js server. There are 2 APIs. One is used by Geth, I mean by all the nodes who send information. The second one is used by the browsers or by external applications. So when you have the second API used by the browser, what you get is this screen, okay? So this is an Angular application where your personal computer needs a lot of processing power to speak WebSockets, the second API, retrieve a bunch of JSONs, process them with Angular, and print the information into the DOM of your browser, okay? And this screen is not very stable. It's kind of scrambled, and it moves a lot, and it's very difficult to find anything. Well, these are more or less instructions, and you can look at quietly later. Here's the GitHub repo and how the Node.js server gets installed. And I added a systemd unit. I prefer systemd over PM2 or supervisord. Here we can, we have to add to the environment the secret of the Node.js server, and restart always, because the application has bugs and it crashes every now and then, and you need them to get back up immediately. You can make use, if you have OpenSSL 111, of an Nginx in front of the Node.js server. So you will get DLS 1.3 with serial round trip time, which reduces the 3-way handshake you have in TCP/IP or in TCP. So making things smoother and faster. And here's a snippet of the configuration for Nginx. As you see, you have to proxy using a couple of headers indicating that this is not plain HTTP, but rather a protocol on top of HTTP, okay? You can write your own code, as I said, to talk to the second API. And this is an example in Python. You would open a connection to the ETHAT server / Primus, which is a framework for WebSockets in Node.js. And you will retrieving JSONs, and as you can see, there are different keys for stats, blocks, block latency, or whatever. And with regard to how it compares to the TSDB, there are no alerts, okay? And it doesn't scale to too many nodes. And most important thing, there is no history. So there is no day picker where you can see what happened in the past. There is some fear among the members that it can slow down the Ethereum network. In my opinion, it doesn't. People suspect that there might be a bottleneck or a single point of failure. But if you trust Golang and the way Get is written with its coroutines, it doesn't affect at all. This is an example, very easy application written with the second API. It's a Python script that retrieves all the information from the Node.js server, it consolidates it, and application is written in plain HTML with jQuery data tables and Ajax. And Ajax retrieves a text file generated by the Python script, and it's very easy to search for nodes. I mean, it's more a tool for the core team, okay? And you can click on the different column headers, and I don't know, you can find here a lot of information. Basically, what you want to know is, for example, if a new node is fast syncing, or if your node crashed and it's not at the chain height. Another alternative would be to rewrite this Node.js server. Here is a skeleton I wrote in Python. The idea is to receive those streams from the nodes and create metrics and forward them or push them directly to an InfluxDB server. Here's an example of one JSON. You construct a dictionary in Python with the 4 elements for Influx. One is the measurement name, the other are the tags, I mean the indexes to look for measurements, timestamp, and the fields that you're going to graph. This is the dashboard of Hyperledger Besu. As you can see in Prometheus and Grafana, it's a nice combination that you can have a bird's eye view instead of node by node. This is, again, an example. Here are Java virtual machine threads, which are gauges. This doesn't make much sense. It's just illustration. And these are the options of the TOML file for Hyperledger Besu. These are the options that you have to configure to get a Prometheus exporter. And if you don't want to be scraped, you can use metrics push enable. If you use Docker, don't forget to export the port you've configured. There is one Grafana dashboard by Pegasus and another more recent one by Planisys. Here are the URLs of Grafana. And another very interesting thing is the Prometheus console, which lets you draft interesting things regarding observability. Here you have the blockchain height, which is a gauge, so snapshot value, and here you have an instant vector, so a few gauges. But then there is an important tool for when you're trying to do a hard fork. A hard fork is lifecycle management for Ethereum networks. In this case, we're going to use a function called predicts linear, which is linear regression to predict the block number based on, in this case, the last 10 minutes activity and for the next 60 seconds. I mean, it doesn't make much sense, but when you're doing hard fork, maybe you want to know, you have to specify at which block number your network is going to switch to the new protocol. So you might use 12 hours instead of 60 seconds. This is what it looks like, represented over time. And another interesting function is the derivative, which shows us that based on the activity or on the growth of the chain height on the last 10 minutes, you're going to have a value of 0.5 in average, which means that we're operating at a speed of 0.5 blocks per second, which is actually 1 block every 2 seconds. So this is the heartbeat of our network. And here it is represented over time. These are the options that you can find in every documentation for both get major version, for both Influx and Grafana. And well, these are a couple of graphs of protocol traffic. Here in 1.8, you might be a little bit disappointed as there is no much information. The information increases drastically in get 1.9. And here in 1.9, I've used as an example a Rinkeby testnet node to show that in ETH/63 there is much more information. Okay, this is not a private permission network, but an example. And well, this is a roadmap. Log shipping, create alerts for nodes that are not syncing, rate limits, and develop an agnostic RPC Prometheus exporter for all kinds of private Ethereum networks, and replace the current Node.js stats. Well, that's it. Thank you very much. And if there are questions, I'm open to answer if I can.